Alright, from here, let's substitute the boundary conditions. This is my slope equation and this is my deflection equation, right? So we are substituting the boundary condition. We say for the first boundary condition, x equals 0 meter, y equals 0 meter. Then for the second boundary condition, x equals to L meter and y is equals to 0 meter. Now this is how it works. You are substituting the first boundary condition into your deflection equation so as to get the constant. From here, me finding the deflection across the length of the beam, I can use this deflection equation, likewise this slope equation. But you observe, I have a constant. For the slope equation, the constant is c. For the deflection equation, my constants are c and d. So I have to estimate this value of c and d. So that's why the boundary condition comes in. Now, substituting the first boundary condition into the slope equation, you then have that e I all into brackets. What's the value of your y? 0. 0 equates it to p all into brackets 0 cube divided by 12 minus p over 6 all into brackets. Now for this guy here, take note of this. When you integrated, earlier when we integrated x minus L over 2 as a whole, right? When we have something like this, recall when we have integral p over 2 all into brackets, okay? When we have integral p all into brackets x minus L over 2, we are integrating with respect to x. But in this case, how do we integrate? Instead of separating by saying px minus pl over 2, performing the integral, we integrated this bracket as a whole, meaning my integral becomes p all into brackets x minus L over 2 square over 2. Now, what it means is that when you want to substitute the value of x into this place, it means you are considering this bracket as a whole, meaning this bracket takes 0. This is hypothetical, it is an assumption, right? You are saying this guy here, p over 6 all into brackets x minus L divided by 2 all cube implies that p over 6 all into brackets 0 cube, meaning this fraction you substituted the value to be 0 and it is taking x here. So that's the idea. It's just an assumption, hypothetical. Though in numerical calculation it is not so. You have to input the exact value of x in numerical calculation, meaning if you are given a loaded beam, let's say you have this loaded beam A, B, you have a point load of 5 kilonewton, 6 kilonewton, 2 meter, and this is 2 meter. The same way from step 1 up to this step that we got slope and deflection equation. That's the same idea that I am going to use to solve this. But when substituting your boundary condition, this won't be the idea that I am going to use. Any value of your x, let's say your value of your x is 10 meter, then you have your 10 meter divided by L over 2. In the subsequent video, I'm going to take more examples to see what we are saying. But moving on, we have that this becomes 0, right? So we are saying that E all into bracket 0 is equals to P all into bracket 0 all cube divided by 12 minus P over 6 0 all cube plus C all into bracket 0 plus D, right? That is 0 is equals to 0 minus 0 plus 0 plus D, which implies that D is equals to 0. Now you've gotten out of this constant, which is C and D, you already know the value of D to be 0. Now, how do you get the second constant? Substitute the second boundary condition, right? Now, substituting the second boundary condition, what do you have? Substituting the second boundary condition, meaning at x equals to L meter, y is equals to 0 meter. Same idea. Anywhere you see x, you are going to put L. Anywhere you see y, you are going to put what? 0. Now, we have E open bracket 0 is equals to P all cube divided by 12 negative P over 6 all into bracket L minus L over 2 all cube plus CL plus D. But we already know the value of D to be what? 0, meaning plus 0. You see the same thing as writing just plus C, because 0 in this case is nothing, right? So I'm eliminating my D. Okay, from here we have 0 is equals to PL cube over 12 minus P over 6 all into bracket. What's the LCM here? That's 2. 2 divided by 1 is what? 2. 2 times this is 2L. 2 divided by 2 is what? 1. 1 times this, what do you have? L. Right? Then square. Then cube it. Or cube. This cube is affecting the whole bracket. Meaning that 0 is equals to PL cube over 12 minus P over 6, open bracket, L over 2 or cube, right? This cube, how do we get L? 2L minus L give us L divided by 2. This cube is affecting the numerator and the denominator, so it becomes L cube over 2 times 2, 4, 4 times 2, 8, right? Meaning that 0 is equals to PL cube divided by 12 minus PL cube, include your plus C. You are substituting this guy, this is it. This whole expression, this is it, and your plus C remains there. So we have divided by 6 times 8 is what? 48, right? 6 times 8, you have 48 plus 6L. Now, mind you, what's our interest? We are interested in knowing the value of C, right? So from here, you then have that 0 is equals to PL cube over 12 minus PL cube over 48 plus CL. Now, take CL to the other side, then it takes what? Negative. Meaning that negative CL is equals to PL cube over 12 minus PL cube over 48. Now, what's the LCM here? 48, right? 48 divided by 12. What do you have? That's 4. 48 divided by 12. That's 4, right? Meaning 4 times this. 4PL cube. Negative 48 divided by 48. That's 1. 1 times this. What do you have? PL cube. Equals to this subtracted from this. You have 3PL cube over 48. That is, negative CL is equals to 3PL cube over 48. Observe that from the left hand side and the right hand side, L cancel L here, right? From the right hand side, you'll be left with what? L square. From here, from the left hand side, this is the left hand side, and this is the right hand side. You observe that L cancel here, L cancel here. You'll be left with what? L square here, right? You'll be left with L square here. Meaning that negative C is equals to, also 3 go here 1, 3 go here 16. Meaning negative C is equals to PL square divided by 16, which implies that C is equals to negative PL square over 16. And that's it. We've gotten the constant C to be negative PL square over 6, and we've gotten the constant D to be what? 0. Meaning, come back to your slope equation. Anywhere you see, put this guy here. Come back to your deflection equation. Anywhere you see C, substitute this expression, and of course substitute the value of D to be what? 0. Now let's substitute. From here, from this slope equation, I know the value of C to be what? Negative PL square over 16. So negative PL square over 16. From deflection equation, I have two constants, C and D. What's the value of C? Negative PL square over 16. Meaning negative PL square over 16. X, we have x, negative PL square over 16x plus 0. But in this case, don't include your 0. Since 0 is nothing, it doesn't mean anything in this equation. So that's it. Meaning, for that particular question, that beam that we are giving, this is the slope equation and this is the deflection equation. So with this slope equation, you can find the value of your slope across any length of that beam. Likewise for your deflection, right? Okay, let's find the slope of that beam. You know, the question says that find the slope and deflection of this particular beam. Now let's find the slope at A, find the slope at B, also find the deflection, the maximum deflection. Let's see how it works. This was the given question. Alright, from here, this was the given question. We want to determine the slope at A and the slope at B. Slope at A. Now, when you want to determine the value of slope at A, recall your slope equation. This is your slope equation, right? This is the equation that I'm going to use to get the value of slope at A. Now, the idea of slope is that this beam, as this beam is, say you have okay, just that your slope is denoted with theta, meaning slope at A, that is theta A. What if it is slope at B? Theta B, right? Meaning that theta A, from this deflection equation, from this slope equation, I have that EI, you know, dy dx means slope, but I'm looking for the slope at point A, meaning that slope at A is equals to px squared over 4 minus p divided by 2 all into brackets x minus l over 2 all square negative pl square over 16. Now what will be the value of x? You are going to substitute. From here, x equals to 0 meter. And the question is why? Observe, when you are calculating the value of, you are calculating the slope at A, right? What's the value of x at A? From here to here is from this initial point to this final point, we have it to be L meter, meaning the starting point x is equals to 0 meter, and for the final point, what do you have? X equals to what? L meter. That is the value of this beam. It is ranging from 0 to L meter. Now you are calculating, you are solving for slope at A, then the value of your x becomes 0 meter. What if you are solving for the value of slope at B? Then the value of x becomes what? L meter. That's the idea. Now let's substitute the value of x into this equation, meaning that EI theta A, which is the slope equation, is equals to P all into brackets 0 all square divided by 4, right? Negative P divided by 2 all into brackets. Now from here, just the same way we did, we said it is hypothetical, right? Meaning it is an assumption. When you want to substitute the value of x being 0 here, then it is affecting this O bracket and not this x alone. Why? Because the idea is when you integrate it to get slope equation, you consider the bracket as a O. So that's what it means here. So from this place, you have negative P over 2, 0, all square minus P all square over 16. Right? Moving on, this is 0, cancel out. This is also 0, cancel out. Right? That is E I theta A is equals to negative PL square over 16. Make theta A the subject of the formula, that is divide both sides by EI. Theta A is equals to negative PL square over 16 EI. This becomes the slope formula. This becomes your slope at A. So this is the equation for slope at A, and that's how it works. Now let's find the slope at B. Slope at B. Now the question is, slope at B, what will be the value of x? Same idea. when you solve for slope at A, meaning theta A, right? What was your value of x? 0 meter. And why? Because the starting point, that's where you have A, and the value of A there is what? 0 meter. Now use that same concept. You are on point B, right? Meaning slope at B, theta B. Now what will be the value of L as far as point B is concerned? This is it. The total length, which is L meter, it is ranging from 0 to L, and the final length is at B, which is L meter. Alright, meaning that x is equals to what? L meter. Now come back to this slope equation. Anywhere you see x, substitute the value of x to be L, then it becomes EI theta B equals to PL square divided by 4 negative P over 2 all into bracket L minus L over 2 all square negative P L square over 16. Now let's simplify further. Meaning EI theta B is equals to PL square over 4 negative P over 2 all into bracket. Of course, I'm going to take the LCM, right? 2 divided by 1 is what? 2. 2 times this, what do I have? 2L negative L all square negative P L square over 16. Right? From here, I have that P L square over 4 minus P divided by 2 all into bracket L square over 4 minus P L square over 16. 2L minus L, that's L. L square, this is it. 2 square, 4, right? Now, solve. Coming further from here, it becomes E theta EI theta B is equals to P L raised to power 2 divided by 4. Open up your bracket. You have negative PL square divided by 8 negative PL square over 16. Right? Now let's take the LCM. The LCM is what? 16. 16 go here. 16 going 4 is what? 4. 16 going 4 is what? 4. 4 times this, what do you have? 4PL square. Right? 16 going 2 is what? 2. 2 times this, what do you have? Negative 2PL square. 16 divided by 16 is what? 1. Meaning that 1 and this guy here, it becomes negative PL square. Right? Equate that to what? EI theta B. Meaning that EI theta B, which is the slope at B, is equals to, what's your numerator? 4 minus 2 is what? 2. 2 minus 1 is what? P. That is, okay, this is how it works. From here, what's the coefficient here? This is 4, this is 2, this is 1. You have an invisible one here. Meaning 4 minus 2 minus 1. 4 minus 2 is what? 2. 2 minus 1 is what? 1. Are you with me? Now, meaning 1 times PL square. You have PL square over 16. Therefore, theta B, divide both sides by EI. That is, theta B is equals to PL square over 16 EI. And that's it. You are done with the slope at B. You observe that slope at A and slope at B, they are the same. The difference is that the slope at A is negative, while the slope at B is what? Positive. What this means is that in this beam, the orientation of slope at A will be different from the orientation of slope at B. Meaning, when this beam is trying to rotate, you might have it in something like this. The idea of slope is that, let's say you have a tangential line drawn. Let's say you have a tangential line like this. Then you have a theta here. You have an angle here. Call that angle theta A. Similarly, let's say you have a tangential line like this as well. You have an angle here. Call that angle what? Theta B. And that's the concept behind slope. So this is slope at A, slope at B. Slope just means the rotation of your beam. So for this slope at A, this is this is the form, this is the value, and for your slope at B, this is the value. What if the question goes further and says that we, knowing the value of the slope at A and B, given that P is equals to 8 kilonewton, given that L is equals to 10 meter, and your Young module, your EI, take note, EI is called the flexure rigidity. EI is called flexure rigidity. So let's say you are given EI, meaning your flexure rigidity as 20 kilonewton per millimeter raised to the power of 4. Then you substitute the value of each parameters so as to get the deflection at each point, which are A and B. So that is how it works. Now, this is for question 1, deflection at A, question 2, deflection at B. Now, for the last question says that find the maximum deflection for this beam. Find the maximum deflection. It says that find the maximum deflection. By maximum deflection, take note, for a simply supported beam, your maximum deflection will occur at the midpoint. Your maximum deflection will occur at the midpoint. Now, ask yourself, if from here to here is L meter, the midpoint becomes what? L divided by 2. Are you me? L divided by 2. Having said that, you already know that the value of your deflection will occur at x equals to L over 2. That is, substitute the value of x equals to L over 2 into this your deflection equation, and that becomes your maximum deflection value for this beam. Let's see how it works. Maximum deflection y max, the value of x is equals to L over 2, right? The value of x for maximum deflection is x over, the value of x for maximum deflection is L divided by 2. This is the idea. You are saying that if your beam is deflected in this nature, you have your y max. This is where your maximum deflection will occur. Now let's substitute the value of x equals to L over 2 into this deflection equation, meaning that EI y max is equals to P L divided by 2, P over 12 all into bracket L divided by 2 cube, negative P over 6 all into bracket L divided by 2 minus L divided by 2 all cube, negative P L square divided by 16 multiplied by L divided by 2. What we did here is that this is P over 12, right? Coming from here. Anywhere I see x, I substitute it as what? L over 2. This is it here. Negative P over 6 from here. Anywhere I see x, substitute it as what? L over 2. And that's it. From here, negative P L square over 16. This man here, multiplied by what? X, which is what? L over 2. Moving on, we have that EI, Y max. Why am I using Y max? We said maximum deflection. So Y maximum deflection, Y max, is equals to P, open up your bracket, what do you have? PL cube divided by 12 times 2 is what? 24. Minus P over 6. Looking at this will cancel out because this is 0. So let's say this has been cancelled out. Then you have negative, this time this is what? PL cube over, this time this is what? That's 32. Right? Now let's take the LCM. Now from here, let's moving on, open up your bracket, meaning EI Y max equals to P divided by 12. Your cube will be affected by this whole bracket, that is multiplied by L cube divided by 8. Why is it 8? 2 times 2 times 2. That's 8. Negative, from here, observe, this will cancel out, right? this will cancel out. Why? Because this minus this is 0. 0 times this, 0. So you are left with negative PL square dot, what's the value of your x? L over 2. Now multiply. You then have that PL cube divided by the product of 12 and 8, and that's what? 96. Minus PL cube divided by 32. Right? Let's take the LCM. The LCM here is what? 96. 96 go here how many times? 1. 1 times this, what do you have? PL cube. Negative 96 go in 32, that's what? 3. 3 times this, what do you have? Negative 3PL cube, right? Then subtract this. Subtract negative 3L cube from this. You have negative 2PL cube divided by 96. Meaning that EI Y max is equals to negative 2PL cube over 96, right? From here, 2 go here 1, 2 go here 48. EI Y max equals to negative PL cube divided by 48. Then from here, divide both sides by EI, meaning Y max is equals to negative PL cube divided by 48 EI. So this is the value for your maximum deflection. For this beam, this becomes the value for the maximum deflection. So this is how it works. Whenever you are given a question under slope and deflection, your steps remain the same. From step 1 up to the last step remain the same. But in this case, you observe that we did a hypothetical absorption, right? Now, when we section after the load the beam was loaded with, right? Meaning this was my beam earlier, and we section in this manner. XX, we section XX at a distance x from the left hand support, right? Now you can as well as section your beam before the load. That is, by the time you section here XX, same process, nothing is changing. I would love you to try that on your own. Same process, nothing is changing. You section before the beam, then by the time you section, no need of you doing that absorption, that hypothetical absorption, saying that the O bracket is considered to be 0. You have your answer directly. But you can as well as go with this. It's still the same thing. So this comes to the end of this video. Then earlier we said there's this similarity between double integration method and Macaulay method, right? Now for your Macaulay method, what we've done so far here is actually Macaulay method. But you can still relate it as double integration method. But the difference is that for your double integration method, it is used when you have a single load on your beam. For this guy here, for this beam AB, observe, I have a single load, and the load in this case is what? A point load. This beam is loaded with just a single load, which is what? Point load. In a case where I have several loads, then it becomes Macaulay method. Those still the same step. But for what differentiates between double integration and Macaulay method is that your double integration, your beam is loaded with a single load. But for Macaulay method, it is loaded with several loads. Mind you, the steps remain the same. All right.